we have discussed what is refraction of light. When light goes from one medium to another medium, like binoculars, there's one more equipment which is a periscope. So I hope you are understanding what is happening here. Applications of refraction. So now we are coming back to refraction. In fact, TIR also was a consequence of refraction only. Students, you have an idea what lenses are like. They are transparent medium having curved surface. So the first ray that we are discussing is a ray that passes through the center of the lens. What are the various possibilities of image formation? So the first that we are starting is, hello everyone, welcome to this next part of the unit waves. Students, we have discussed a lot already and I hope you were with us all this while and you've seen all the previous parts of this particular unit where we have discussed what are the various types of waves, what are the various characteristics of waves, specifically discussing sound and light. Today we will take this further and almost conclude this unit of waves, and finally we will come up with the topical previous year questions where we will apply all this what we have learned. Right, students? So without wasting any time, let's get started. The topic of the day is first to discuss how do our eyes function. Right, students? So I have already told you that whenever you are viewing something, the main thing about that is that you are able to accommodate any object, whether near or far, at the screen of your eye, which is the retina. Right, this is what I am trying to show here first, that how do our eyes function, and then we will discuss what are the common defects or problems that we can have and how they get rectified by using spectacles, right? So the first thing, our eyes contain a converging lens which forms an image on the retina at the back of the eye. So as you can see, the rays are coming and our eye lens is able to focus them on the retina. The lens in our eye are flexible and muscles can change the shape and strength of the lens. This is very important, students. Let me quickly revise that, if you have a stronger lens, that means it is more curved. The muscles are going to stretch and make it more curved. In this case, you will have more power of the lens. It is becoming stronger here. So that means it has more power to converge, right, students? While when the muscles are relaxed, it is less curved. In this case, it is a weaker lens. Okay, now when do we need this and when do we need the other situation? When do we need more power? When do we need less power? So imagine when you are viewing something very close to your eyes. In that case, what happens is you get a diverging kind of a rays, right? And during that part, you will need the eye to be stronger, and that is when it will be able to accommodate that on the retina. So this is when you need a comparatively curved shape of the lens, okay? While when you are viewing far off objects like a television, then the rays are already very far off. It is like parallel kind of a situation. Then you don't need much power. So that is why when you are viewing anything on the mobile phone, that is like more harmful as compared to the television, because during the television your eyes are relaxed, but when you are viewing something on the mobile phone, then your muscles are stretched and that builds up a strain on your eyes, right? This is when you need less power. So the shape of the lens at this time is like less curved, right? Okay, the light from the closer object is diverging, so the lens need to be thicker and stronger. All this I have written. So today's class is mostly theoretical, but all this knowledge you should have. So I have written most of the content that you would need to know here. Alright, students, diverging light from a close object needs a stronger lens and parallel light from a far off object needs a weaker lens, right? Some eyes are unable to change their strength enough to focus on either close or distant object. An extra lens worn as spectacles or contact lenses can work with the eye to let it focus as needed. Write down. Write this important information, then we move forward. Alright, students, so now you are able to understand how this is functioning. So let's talk about short-sightedness. So this person is short-sighted. That means they can see things close by, but they are unable to focus on the objects which are far off. So short-sighted person, what is the defect? They are unable to see far off objects. All right. So a person with short sight can see close up objects clearly, but cannot form a clear image of the distant objects. So which is the problem in visualizing this particular state? Okay. Now what can be the cause of it? The image is formed in front of the retina. So when the rays are coming from a distant object, they get converged before the retina. And what you get at the retina is a blur image. Okay, students. So you get a blur image. Why? Because they are not sharp image on the retina. So they are converging first. What can be the reason the image is formed? This is usually because the eyeball is slightly long, so that the rays meet in front of the retina. So the eyeball is slightly long, or maybe the eye lens is too converging, like it is having more power to converge. It is converging the rays even before the retina. So we need to diminish this effect of convergence. We need to make it converge less. What can be the alternative? Using a concave lens, which is a diverging lens. So when you use a diverging lens, that extra convergence that was happening gets in a way minimized. So you use a diverging lens, the rays get diverged first, and then they are able to focus properly on the retina, right, students? So to correct this, a diverging lens is used to make the rays from the distant object diverge. Okay, the eye lens is then able to form a focused image. Figure shows the problem and how it is corrected, right, students? So I hope you are able to understand. So whoever is wearing a spectacle for far vision, so they are able to see nearby objects, but they are not able to see far off object, those people are called short-sighted people, right? So they can see nearby object but not far off objects. So what is the problem? The rays are getting converged before the retina. So they wear concave lens. So their lenses should be such that they are thicker at the ends and thinner at the center. Right, students? So I hope you have copied down the important stuff. Now let's talk about the vice versa case, that is long-sightedness. So a person is long-sighted, that means they are able to focus on the far off objects but are unable to focus on the nearby objects. So that is when they need reading spectacles, right? That is when they need reading spectacles. So whenever you are seeing something which is close, you are having more diverging rays and you need more convergence. So maybe their eyes are not powerful enough to converge that. That can be due to aging. With aging, the ciliary muscles, the muscles responsible for converging, are not strong enough. They are unable to stretch enough, and that is why they don't get enough convergence. Or it can be due to the fact that the eyeball is too short. So that is why the rays are unable to converge, as you may see in the diagram, that the rays are unable to converge on the retina, like retina is way too close either, or the eye lens is not converging enough, and you need to enhance the converging power. So for that you will need a convex lens, student. So whenever anyone is using a reading spectacles, they are having convex lens in their spectacles, right? So a long-sighted eye can focus on distant objects but cannot see close by objects. This can be because the eyeball is too short or the lens cannot become strong enough, right? A converging lens causes the rays to converge, allowing the eye lens to form a focused image of close by objects, right? So figure A shows how the problem is and figure B shows how this has been corrected, right? Easy, students. So now I hope your whole perspective of seeing anyone wearing spectacles has changed. Immediately you would know what kind of a lens they are wearing, whether their problem is to focus nearby objects or to focus far off objects. So any person who is long-sighted can see far off objects but cannot focus properly on the nearby objects. Right, students? So the next thing is light dispersion. So the eye part is done, and now we are talking about another phenomena. So we have discussed about refraction, we have discussed about reflection, we have discussed about total internal reflection. Now we are discussing a very different phenomena that causes the formation of rainbow. If you have ever seen that, is dispersion of light. Now, dispersion means whenever it's like white light. So, whenever we say white light, that means all the components of light are there. That is violet, indigo, blue, green, red, orange, yellow, whatever, VIBGYOR, whole VIBGYOR, right? So, that splits. Now, why does that happen? So, different colors, different wavelengths, different frequency refract by different amounts. So, whenever you pass white light through an object like a prism, they all suffer different refraction, causing them to split. Okay. So what are the three remaining points that we are going to learn? Components of white light, that is what I just told you, electromagnetic spectrum, and then we will discuss about uses and harms of electromagnetic spectrum, right? So white light is composed of 7 different colors. VIBGYOR, this is how I call it: violet, indigo, blue, green, yellow, orange, red. When sunlight falls on a triangular glass prism, a band of colors called a spectrum of light. So we call this as a spectrum of light, right? The effect is termed as dispersion. So dispersion is basically splitting up of white light into its component colors, right? So you can copy down the important stuff and then I will show it through a diagram, right? So you must have all seen this diagram. So what is happening? This is a prism kind of a structure where we have understood that light gets deviated, but here we have white light, and when it passes through the prism, it spreads. Remember one thing, students, that red color suffers minimum deviation. So VIBGYOR, okay, red suffers minimum deviation, okay, and violet suffers maximum deviation. So keep this in mind. So how do you cross check? So this was supposedly the path of light. This is where it was supposed to go. Red suffers the least. This is starting from red and ending at violet. So red is always closest to the original path. Many times you will get questions to identify whether this will be red or this will be red. So you should know that the red will be closest to the original path. All right. So different colors travel with same speed in air. So in air there is no difference. In vacuum almost there is no difference, but in different medium like water and glass, different colors, will have different speeds. So 3 into 10 raised to the power 8 is the speed of light, all components of light, only in vacuum. In any other medium, different components will have different speeds, and different speeds will cause different refraction. Okay. So this causes each color to bend inside the prism with different angles, causing dispersion of light. Red has the highest speed in prism while violet has the lowest speed. Red has the lowest refractive index while violet has the highest, right? That is why violet suffers the maximum deviation. So you should always know, right, students? All right, very quickly then, let's talk about the remaining part of this chapter. So what if we go beyond this? So we were discussing only VIBGYOR, but the sun has to offer more. So the radiations that we receive from the sun or in general does not only contain of visible light, but there are different components too. That is what we are exploring in this part. We are thinking beyond light, which we cannot see, which we cannot see after reflection, but is there because they cause different effects. So for example, in thermal physics we have learned that infrared light, it causes heating effect. It has the major role to play in heating effect. So they are there. We can feel their effect in some way or the other, but we cannot see them. Our eyes are not sensitive to that. Okay. The electromagnetic spectrum is made up of a group of electromagnetic waves which all have the following properties. They are transverse in nature, students. So I hope you realize that, let's say if the wave is traveling in the x direction, then the disturbance, the electromagnetic disturbance, is always perpendicular. So electromagnetic disturbance, we will learn about them. It's like in the form of electric and magnetic field. So the disturbance are always perpendicular. They are transverse. All right, students. Next, they consist of combination of electric and magnetic field. They travel with the same speed of 3 into 10 raised to the power 8 in vacuum. Components of electromagnetic spectrum have same speed but different wavelength and frequency. As I have told you, they all have different frequencies. Gamma has the greatest frequency and radio has the lowest frequency, and they all obey the standard equation of wave, that is V is equals to F lambda, that we have already talked about, right? So you can copy this down again or take a screenshot of this, and then we move forward. All right, students. So the next thing is this. So I will take the name of all the bifurcations that we have done. So the first is radio wave, which we use for, you know, nearby communication like Bluetooth. Okay, that is radio wave. Microwave we use for satellite phone or television communication. So when we are going in this direction, the frequency is increasing, and when we are going in this direction, the wavelength is increasing. So the highest wavelength we have radio, and the lowest wavelength we have gamma, but gamma is the highest frequency. So yes, radio wave, microwave, infrared radiation, visible light of course, then ultraviolet light, then X-rays, and then gamma rays. So we go on the right side, we have shorter wavelength or more frequency. We go on the left side, we have longer wavelength or a smaller frequency, right? So we will discuss one by one their uses and harms. At least a couple you should know, like at least 2 uses you should know, so that you are able to write that if asked particularly in your exam. So I hope you understand what are electromagnetic radiation or electromagnetic waves. These are basically electromagnetic disturbances. Light is also a part of it. So light is a subset of it. There are more type of radiation apart from light. Light is something that our eyes are sensitive towards, right? I hope you have taken a screenshot of this, and then let's talk about the uses. So I have given you a brief. You can also Google it, you can also refer it from any textbook or our own notes, there's no problem. So you should know 2 valid, and when we will go through the marking schemes, then we will already understand that what uses, you know, are preferred over there, right? So radio wave, long, medium and short wave radio, TV, astronomy, radio frequency, and so these are majorly used for communication, right? Microwave use mobile phone, satellite communication, and of course in microwave ovens for heating purposes, right? Then infrared is of course the major thing for heating effect, and it is also used in alarms, in sensors, in remote controls. The light that goes from remote control is infrared light, you cannot see that. And night vision cameras, of course. Then visible light, seeing, communication, optical fibers, photography, photosynthesis. Even if we are not doing it, but photosynthesis is very important for us. That is a major source of food, and photosynthesis is majorly using the visible light part of the spectrum, right? Ultraviolet light, sterilizing food, sterilizing water, security marking, detecting fake banknotes, etc. X-rays, of course, to observe the internal structure of objects, including human bodies, security scanners, and also detecting cracks and stuff like that. Gamma rays, sterilizing medical equipments and food, detecting cancer and treatment of cancer as well, right? Harms, radio waves are almost harmless, okay? And microwave can cause internal heating. So imagine you know, a microwave and you putting your hand inside it, it can cause heating. It can cause the heating of the water part of your body, which is 70% also. So yeah, skin burns, infrared. Then visible light, of course there are no harms as such. Then ultraviolet light, damage to surface cells and can also cause blindness, too much exposure of that. And then is of course gamma rays and X-rays, which are considered the most harmful part, but that can cause mutation of cells and that can cause cancer as well, right students? So take a screenshot, then we move forward. All right, so the next thing is communication using electromagnetic waves. So you know, one thing that you should know, there are 2 kinds of satellites. One is geostationary satellite. So when this is, let's say, the earth, let's say this is the earth, then what happens is that there are certain satellites that there are certain satellites that revolve such that their time period of revolution is 24 hours, same as the time period of rotation of the Earth. So they always remain at a particular position with respect to Earth. Even if Earth is rotating, they are rotating with the Earth. So in a way they are revolving, but they are moving with the Earth's rotation. That is why they always appear stationary. So they are very important in communication, for communication purpose. Then there are certain satellites which are used for imaging, photography and stuff like that. They are very close to the Earth's surface. These are very far off from the Earth's surface, like these are approximately 35,000 kilometers. But then there are low-lying satellites which are very close to the Earth's surface, like not exactly at the Earth's surface, but let's say 300-400 kilometers away. So again can be treated as very close. So these satellites are important, they are crucial. Communication majorly is happening through satellites these days. So Earth has many artificial satellites, many of which are used in transmission of information carried by electromagnetic waves. Most artificial satellites communication uses microwaves. Some of satellite use communication are in geostationary orbits. So these are geostationary. Geo means Earth, so stationary with respect to Earth. This means that they orbit at the same speed as Earth turns, and so they stay at one point on the Earth's surface. They are about 35,000, as I said, above the Earth's surface and are positioned above the equator. These satellites are powerful and can transmit large amount of data. This makes them suitable for satellite television and some satellite phones. The waves travel a long distance to the satellite, meaning there is a slight delay, making it more difficult to have a conversation. That is why we then have low orbit satellites. These are the low orbit satellites, these are the geostationary satellites. These two variety you should know. Alright students, so now let's talk about the last slide that I had to discuss today and wind this up for a while, and then you go through all the stuff that we have done and we'll come up with the topical previous year question, probably starting with May, June 2024 in this particular, like just after this. Alright, so digital and analog signals. So digital is like which can acquire discrete values, and analog signals are which can vary randomly and continuously and can acquire all the values. You can have many examples you might have seen. So for example, there can be a digital clock where you can only see 1 second and then 2 seconds and then 3 seconds, and then there can be a sweep movement clock where it is a continuous variation. So if it is a continuous variation, that's analog, and if it's discrete variation, then that's digital. You should know that. What do you mean by a signal? So signal is basically information in the form of electromagnetic signals. They can be in the form of currents if they are going through wires, or they can be electromagnetic waves as well, right? So electricity is used as power, like electricity for operating different appliances or in transferring data like internet and phone calls. Electric voltage used to transfer data is known as signal, as I told you. These are of two types. So analog signal, voltage that vary continuously with time between maximum and minimum values, okay, and signals that have only discrete values, high or low. So most of the computer devices, we call them digital devices because they function between two voltage pulse, like 0 volt and 5 volt. So this is how a digital pulse would look like. And analog can be any random variation, as you may see. They can acquire all the values. Here you can go either to 0 or to 5. Here you can go 0, 1, 2, 3. So if you can acquire all the values, that's like analog signals. Examples: analog meters, pointer ammeters, voltmeters, variable resistors. These are all analog, as we know. And switches, digital meters, CD players, voltmeters, telecommunication. So digital ammeter, voltmeter, these are all examples of digital meters or devices or signals, whatever you may call it. Definition: voltage that vary continuously, so that I have written already, and these have only discrete values. Okay, so you should have an idea, but what is the advantage of digital signal? You should know that. So they are clearer. Digital signals are the latest technology. They are clearer. They can be reproduced. So what happens is the signal loses strength. So when you are talking and let's say far off distance, your signal loses strength. Sometimes they need to be recreated to transmit further. So if recreation has to be done, it is much easier for digital signals. Okay, carries more data, more combinations are there, easily repaired. Okay, again, eliminating noise or detecting noise is easily processed and can deal with compute. So just to give you an idea that there are two types of signals, digital and analog. Digital means discrete values and analog means continuous variation of voltage or current. I hope students you were able to understand whatever we tried to convey today, but majorly our focus was on three things. First is of course the defects in the human eye, that is short-sightedness and long-sightedness. Then we had discussed dispersion and electromagnetic spectrum, and the third part is communication through satellites and digital and analog signals. So I hope this all information you have grasped, and you will now start with the questions, and soon we will be coming up with the topical questions, and as always we will also come up with the past question papers. Right, students, do let us know if anything else you want us to do that can help you achieve your desired result. We will be more than happy to help, and that will really keep us going if you keep commenting and letting us know that you are really into it, and that motivates. Right, students, thank you so much for your time. I will see you very soon. Bye bye. If you enjoyed this video, please don't forget to like, share and subscribe to our channel.